Hello, my name is Ole Christian E. Kornes from WebAppTech AS in Norway. In this video, I would like to present the Advanced Custom Function plugin for FileMaker, called ACF plugin. The ACF language is a high-level block-structured custom function language that lets you write highly effective custom functions that is clear to read and understand. The ordinary custom functions in FileMaker is excellent when it comes to small calculations. When implementing algorithms in custom functions, they tend to be hard to read for the developer. The lack of loop control techniques make developer implement recursive methods instead, something that makes the function even harder to read and understand. Such methods also use more memory to execute. In the ACF language, you have the block structure that makes the function more comfortable to read and understand. They look like a FileMaker script, but they are functions. The plugin contains a compiler. Compiled ACF functions execute fast. In the startup script of your FileMaker application, you can choose to load pre-compiled binaries, or you can compile the sources. The pre-compiled binaries are base64 encoded objects, so you can store them in text fields in your preference table. You can have many functions on the same file. The pre-compiled binaries are cross-platform compatible, so you need only one set of binaries whether your clients run Mac or Windows 32 or 64-bit. For editing your ACF functions, it is best to use a plain text editor. For Mac, I am using TextMate, and for Windows, I use Notepad++. We have developed syntax coloring additions for those editors, so the source is easier to read. Usually, in PHP or JavaScript, you have many functions on the same file. You put a package header that names the package in the top of your source. You can load or compile as many ACF packages as you like, but having a name makes us able to replace only the ACF package you recompile or reload. In our demo files, we have set up 4 packages, but you can quickly expand with more. In this demo example I put together here, I have compared 3 different methods of implementing an algorithm. We are looking at annuity loan calculations. To calculate the periodic payment or monthly payment for an annuity loan, we use a simple formula. However, to calculate the effective interest rate, it can't be calculated with such a formula. I have searched the internet and found tons of articles about it. There is just no formula for calculating the interest rate of an annuity loan. They conclude all. So, to calculate the interest rate, we need to implement an algorithm that does trial and error to close in the interest until we have the answer. The technique I am about to show do this in approximately 25 iterations. I have created an ACF function to do it, an ordinary FileMaker recursive function, and a FileMaker script. They all give the same result but consume different time to do the task. Let us have a look at the FileMaker script first. Here it is. The parameters are the loan sum, let's say 100,000, the number of years for the loan, let's say 10 years, the number of payments per year, let's say we pay monthly, so it's 12. And finally, the periodic or monthly amount. I have made a custom function that calculates the amount with this formula for a given interest rate. Then we start at 100% and loop this calculation with 100, 50, 25, 12.5%, and so on until we have the payment that matches the given amount. We have some tests here for too little payment for the function and too much down here. The interest rate can be between 0 and 199.99% when we start at 100%. Now, let us look at the ACF function here. Pretty similar, isn't it? We have this repeat until loop here, and we have an if then else and if here. We have the payment calculation as a separate function up here that we do call down here. We test for the too little payment here. Just number of payments times payment amount is less than the loan sum. The until condition here, we check if we are close enough. The second part is when the step becomes very small, then we exit 2. This condition prevents us from having an endless loop if we can't find the result. Okay, so let us look at our normal recursive function here. This function has 2 more parameters, the interest rate and the step. The function tests with this interest rate, and if it does not match, we call ourselves with a modified interest rate, either up or down depending on the result. We also here check if enough payment, or down here if it can't be calculated. So now, we have these 3 methods. Let us compare them. When it comes to execution speed, we count microseconds. First, we test the ACF function. See, 250 microseconds, that was fast. 25 iterations in our loop calculating in a quarter of a millisecond. Let's test the ordinary custom function here. 2250 microseconds is almost 10 times longer. And finally, we test the FileMaker script. 4500 microseconds, it's almost 20 times longer. Well, for a button action to do a single calculation, it is no practical difference. The user would not be able to see any difference. However, it is a number of times doing this that makes the difference. Let's say we have this as an unstored calculation down in our table. That calculation alone will, for a 2000 record report, use a half second using our ACF function and 4.5 seconds using the recursive custom function. Using our script, we would need to loop the records first to calculate the value and then run the report. That alone, we use 10 seconds only to calculate this value, not counting for the loop. Okay, let us have a look at our development environment. This layout is a service layout for the ACF packages. It is for developers only, so no end user should ever see this. It's just for your eyes. It's a working example. Customize it for your own needs and likes. When we compile our ACF packages, we generate a base64 encoded binary. We don't use container, text field only. It's 2 KB++ text field, and it lets us see some description of the package when it was compiled in the top here. We have 4 tabs for 4 different packages. It's quick to expand with some more if needed. You can include this layout into any project to use ACF. We think that it's convenient to be able to compile and test directly here. So we have a source code tab for the 4th package. Edit opens the text file, or if the file doesn't exist, a file save dialog shows up to save it as an ACF file. Here it opens in TextMate. I can edit the source code here. Let's say I would like to see what this loop is doing. I uncomment those lines, calc of the diff and the print. This prints to the console function in the plugin, so we can ask for it to see what the function is doing. So save. And then back to the source tab. We load the edited source from the file here and do compile text. Alternate, we could just hit compile file and that's it. Now we head back to our example and run. We see now that we have added 200 microseconds to the time because of this console print. Now we look at the console. Hit the console tab and refresh. See here, we have the iteration number, the applied interest, the payment result for the interest, and the difference. It is 25 iterations in the loop. Each time we refresh the console, the plugin clears it to the next run. In this way, we don't have a lot of history on the console. This example can be downloaded from our website, so you can test or play with it. How did this ACF language came up? Well, we intended to do something to improve the speed and reliability of the development cycle. We wanted to do something similar to scripts, but for functions instead. A quick search on the internet for FileMaker custom functions, you get tons of them, and many long and hard to grasp. What the function is doing, or how it is doing the calculations. To example, 200 lines long with a lot of structure in nested ifs and cases, ending with a ton of end parentheses. The logic is sometimes hard to grasp because the calculations are made up with one-liner constructions. Having loops, three kinds of loops: for loops with a loop control variable, while loops with an initial condition, and the repeat until loops with an end condition. We have included a set of functions in the ACF language. The most common ones. In addition to that, you can use the whole set of FileMaker functions as well, directly from the ACF source. In addition to that, call other ordinary custom functions and external plugin functions. We included SQL functions. You can use FM's execute SQL directly, or you can use ours that let you do insert, update, and more. In addition to that, we have array concepts. When you pull some data from the database using an SQL functions, you get the data as a delimited list. If some of the fields contain several lines, we run into trouble. A conventional technique is to use other delimiters, and then do substitute to form a list in a variable, and pull each value using getValue. Several lines in one field make trouble for this technique. Instead, we have functions to retrieve the records from the SQL query, one record at a time in a for loop, as an array of the columns. Then you can address the columns using the array index instead. You don't have to worry about fields containing several lines, as they will be pulled as they are. Access to FileMaker variables and fields come naturally, just as you would do in an ordinary custom function. Setting the value of a field cannot be done directly, but you can use SQL functions instead. That is the same as for ordinary custom functions. The return value of your function can of course be set to a field using a setField script step. We want to have regular expressions and throw function to abort execution when exceptions occur. A console function to print debugging info to simplify the debugging and quality control of the functions. This was all for this video. You can read more and download at our website acfplugin.com. Thank you for listening.